So the next big thing we're going to be doing is Hooke's law or Hooke's law. Uh, this was discovered by I believe his first name was Robert Hooke. Please correct me if I'm wrong. And it essentially says that the restoring force of an elastic object is proportional to the negative of the displacement from equilibrium position. Now, negative of the displacement, what should that remind you of? Well, this. Now, of course, because acceleration is just force divided by mass, as you can see, force, negative displacement, Hooke's law. So, as you can see here, we already have that I've written down that ma is proportional to negative x, and because A is proportional to minus omega squared x, we were able to calculate omega. We're going to do that in the next slide. One thing to keep note of is that the proportionality constant is just a general k, and it sort of represents the stiffness of the string. So if you compare, say, like a piece of plastic to one of those rubber shocks on big monster trucks, then obviously the stiffness is going to be different, and it's going to be much harder to compress the shocks on the big monster truck compared to, say, like a plastic spring. So actually, how do we calculate it? Well, it is a bit of a long-winded process, but here it is. So we're defining that the force is minus kx, and acceleration we know is minus omega squared x. So it leaves that ma is minus k over x. Now, there's a couple of ways to do this. You can just directly divide by m, or you can say that, well, it can be written in the form m omega squared x coming from circular motion. And then, of course, we can divide both sides by the x's, divide by the m, or you can actually just go from this step, so ma is negative kx, dividing by the m, and I'm going to write it like this. And so we can write omega squared is k divided by m, which will again get us this relationship here, that omega is square root of k over m. So you can therefore write the acceleration as just kx over m, coming from a equals minus omega squared x. So it should actually be negative because we didn't consider the negative case here. Or you could actually sort of leave it as a plus minus case. But we tend to take the absolute value of things. We don't really care about the vector stuff too much. It's not to say that it's not important, but when doing Hooke's law calculations, we tend to just keep the acceleration in modded form. So it's just kind of not stipulation, but sort of in a way to keep things looking nicer.